All right, so let's pick up from yesterday where we left off. Yesterday, we were talking about the intensity of the sun on the planet Earth, and that at certain times of year it's more intense, and other times of year it's less intense. Obviously, in the wintertime, as you can see here in the model, the Earth is tipped away at 23 degrees roughly. So this is set to December down here on the bottom, and it's winter. So as the sunlight is cast upon the Earth, it spreads out over a greater area. So the same amount of energy is hitting the Earth. It's just the energy per square, maybe per square mile, is less in this part of the model. Then as we rotate it, right, this is going to bring us towards our spring equinox, meaning equal daylight and sunlight for everyone on the planet, or at least where you live. We can see right here that the sunlight is cast roughly evenly across the planet. And as I rotate it around towards summertime, we're tipped inward. So the northern hemisphere is getting more intense sunlight. And on the southern hemisphere, they're getting less intense sunlight. And of course, the last one, I don't know if you can see it in the video. If I slide it over this way, this is our fall equinox, equal sunlight, daylight, and finally all the way around to where we started. One of the things I want you to note, and I'll try to bring this up a little closer for you, as I spin it, pay attention to the way that the Earth rotates, and it's kind of hard to see in this model, but if you look at it from above, the Earth is spinning this way, which is in a counterclockwise direction. So what does that mean for the next part? Well, today we're taking a look at the Coriolis effect. Well, I have a model of the Earth here, and in that model of the Earth, if you're looking down from the top of the Earth when it's rotating, it's actually spinning counterclockwise. Okay, this is clockwise, counterclockwise. So basically, what happens with the air that's above the Earth is when it's close to the equator, it heats up, it rises, and it goes north. And as it gets towards the North Pole, it cools down and it flows south. So it's kind of just a looping, a cycle here, back and forth. Equator, heat up, rise, push to the poles, cool, settle down, go along the land, and that's a constant motion. Well, that would be fine if the Earth wasn't rotating, but the Earth rotates. So in that same motion, as it's cooling, the cooler air from the North Pole gets pushed to the south and it curves due to the Coriolis effect. So that cool air, as it settles, gets pushed down to the bottom. Okay, so we're looking at it spinning counterclockwise. So the opposite happens on the South Pole, and the air gets pushed in the other direction. So we can see in the northern hemisphere here and the southern hemisphere, both of these air pockets are cooling down and then traveling back towards the equator. Now, you know, when it hits the equator, it heats up again. So this time the air gets pushed that way. And the reason why that's happening is that the Earth, if you choose a spot in the Earth, like right here, for example, this spot in the Earth has to spin much quicker to make one full revolution than a spot, let's say, further north, because then this spot only has to travel that small distance. And for up here, you're really only traveling a very short distance. So anybody up here on the planet, in a sense, is traveling slower than all the people down on the equator. So what does that mean? It means this air here, when it heats up, it's being moved very quickly this way. And this air coming down, it's moving much slower this way. And when those two collide, you can see they're working against one another. One's going this way, one's going this way. And that's what causes those circular motions that make hurricanes, especially in this part of the world by the Caribbean. So the Caribbean's right near the equator, and the cold air comes from the north one way, warm air from the south the other way, and it ends up spinning this air and causing those weather storms. But for our basis today, we're just looking at what causes that air motion, the movement of air on the planet. So just to recap, air heats up on the equator, it rises up, it goes north, it cools down, it settles, and it pushes down south at a slower rate than it did when it was moving north. Okay, so that's the little demonstration there. We can move on to our next part.